Buoyancy. Anyone who has tried to push a beach ball under the water has felt how the water pushes back with a strong upward force. This upward force is called the buoyant force, and all fluids apply such a force to objects that are immersed in them, experience buoyant force. So buoyancy is a familiar phenomenon. A body immersed in water seems to weigh less than when it is in air. So when the body is less dense than the fluid, it floats. The same when human body usually floats in water, and a helium-filled balloon floats in air. So no matter what its shape, the buoyant force pushes it upward, according to Archimedes' principles that was discovered or explained by Archimedes. Archimedes' principle states that any fluid applies a buoyant force to an object that is partially or completely immersed in it. The magnitude of the buoyant force equals the weight of the fluid that the object displaces. Now let's consider this figure. Let's say we have here our object with a density object. Yeah, in a particular, yeah. Then we have here fluid where it is submerged with a particular fluid. So getting the buoyancy is a difference between the force applied by the fluid to the object and the force applied by the object due to the gravity. Let's say this is F1 and this is F2. So the difference between the force is our buoyant force. Okay, so let's change our subscript. So instead of 1, let's say 2. So this is F2 and F1, which arrive as is our equation here. That according to pressure, that force is equal to the product of pressure and area. That's why we arrive here with pressure 2 times the area minus pressure 1 times the area. So this area considered is the surface area of the object that have contact with the surface of the fluid. Okay, so we know that the area between them is equal. Then we can have the difference between the pressure times the area. And according to our discussion of pressure by depth, the difference between the pressure is equal to the specific weight times the height. Remember our formula that P2 is minus P1 is equal to um, density times gravitational acceleration times y2 minus y1. Thus, we have here our formula for buoyant force. And according to Archimedes' principle, the buoyant force is equal to the weight of the fluid that being displaced. So imagine um, we have an object that being submerged above the fluid, over fluid. Then there will be a difference in height or depth of the water. So we know that there will be a displacement or changes in the weight of the fluid. Now look at this. We have density times gravitational acceleration times height times the area. And we can see here that height times area is equal to volume. And density times the volume is equal to mass. Then multiplying mass with the gravitational acceleration, then we will have our formula for the weight. So simply, buoyant force is the force exerted by the fluid toward the object to keep it either float or sink. Now, let's try this example problem. A solid square pine wood prop measures 4 meter on side and is 0.30 meter thick. Determine whether the raft floats in water, and B, if so, how much of the raft is beneath the surface. So, how much raft that being asked here is the height or distance h or the depth of the pine wood that being submerged on the water. Okay, so to determine whether the raft flows in water, we will compare the weight of the raft and the maximum possible buoyant force that the object will experience when it is being submerged in the water. So to get the weight of the raft, it is equal to the mass of the fine times the gravitational acceleration. So since we have no given for the mass, we can get mass by getting the product of density, the fine, and its volume times the gravitational acceleration. Okay, so the density of the pine wood is equal to 550 kilogram over cubic meter times the volume of the pine, which is 4 times 4 times 0.30, which is equal to 4.8 cubic meter times the gravitational acceleration, which is 9.8 meter per second squared. So calculating this one, we can get the weight of the raft, which is equal to 26,000 Newton. Now, let's get the maximum possible buoyant force that the raft will experience by getting the product of the density of water, the volume of water that being displaced, and the gravitational acceleration, which is now equal to the density of water, 1,000 kilogram per cubic meter. So the volume of water that being displaced is equal to, take note, it is the maximum possible. So let's just imagine that the pine wood is totally submerged underwater. So we will use the volume of the raft as the volume of water being displaced. So the volume of water is 4.8 meter cubic and the gravitational acceleration of 9.8 meter per second squared. Then we will have our buoyant force is equal to 47,000 Newton. So comparing the value of the weight and the buoyant force, we can see that the maximum buoyant force is larger compared with the weight. Thus, our raft will float over the water. So simply, in simple terms, we can determine whether it will float or not by simply looking at the density of the two material. So density of the pine wood is much lesser compared to the density of water. Thus, it will float. So compare it with solid material such as steel, that it has a larger density compared with water, then a steel will sink underwater. Okay, so let's proceed with letter B, where we are asked to look for the height in which the raft will be beneath under the surface. So using the formula, the buoyant force is equal to the weight is equal to the density times the gravitational acceleration and the height or the depth that being submerged underwater times the area. So to get the height, we will get the quotient, or we will divide the weight of the raft over the density of the fine times the gravitational acceleration times the area. Therefore, the weight of the raft is equal to 26,000 Newton over, sorry, we will not use the density of water. Instead, we will use the density, no, instead of using the density of the fine, we will use the density of water. Why density of water? Because we will use the changes in depth of the water, or the fluid. So density of water is equal to 1,000 kilogram per cubic meter, and the gravitational acceleration of 9.8 meter per second squared times the area, which is equal to 9.8 meter, ano, 9.8, 16. The area is 16 squared. Okay, therefore, our height is equal to 0.17 meter. So just imagine that the given thickness is 1 and 0.30. And this surface is a square which is has a side of 4 meter. So this area, which is also the same area, surface area under, will experience the buoyant force. So that's it. So let's try to solve this problem.